Hello, my name is Michaela and I'm going to be introducing y'all to calorimetry. We're going to go over the history, the function, appearance, mathematics, and importantly, the calorimeter's purpose. But before we get into the history of it all, let's get a grasp of what a calorimeter is. The calorimeter measures the amount of heat used in a chemical reaction or physical process. Different types of calorimeters include adiabatic, differential scanning, DSC, sample preparation, isothermal titration, multiple mode, oxygen bomb, photocalorimeter, etc. The most popular calorimeter is the adiabatic calorimeter. It increases reaction rate when heat is generated by material, thus increasing the temperature. An indirect calorimeter measures the respiratory gases like oxygen and carbon dioxide rather than heat. This helps humans and animals because it determines energy output the organism provides. Based off of the oxygen and carbon dioxide output, the scientists may be able to determine macronutrient utilization, which will help determine any metabolic disorders. Now let's get into the history of it all. In 1761, Joseph Black had discovered that heating ice at a melting point doesn't increase temperature, but increases water abundance. This was a milestone for the beginnings of thermodynamics. In 1780, Antoine Lavoisier used heat from a guinea pig's respiration to melt snow, proving respiration to be slow combustion. In 1782, Lavoisier and Pierre-Simon Laplace invented the ice calorimeter to determine heat production using chemical changes. In 1789, the calorimeter was named by Lavoisier. In 1894, Max Rubner found out about indirect calorimetry by experimenting on animals' heat exchange inside a body of water connected to a respiration chamber. Here's a couple examples of what a calorimeter looks like. On the left, it's a simple calorimeter. On the right, it's a commercial calorimeter. A simple calorimeter can be made with 2 styrofoam cups, a cardboard lid, a thermometer, and a metal sample, and a stirring rod. Here's a really helpful video that has helped me out understand how calorimetry works, and hopefully you will understand it better too. Now let's get into the formulas. We use the specific heat formula to find the temperature change. This calorimetry experiment will show endo and exothermic processes. For example, if the temperature of the material placed in the calorimeter is warmer than the water, then an exothermic process will occur for the material, which means the heat was released, thus making Q, or heat, equal to a negative number. The water will have an endothermic process occur, which is heat gained, which would make Q, or heat, equal to a positive number. This scenario will give you an equation that looks like this. So, what is the purpose of using the calorimeter? Well, they show us heat gain or heat loss, which is endothermic or exothermic processes. Similar to Joseph Black's example, you could determine these processes by placing an ice cube in your cup of water. With a calorimeter, you can determine the heat loss or heat gain with the specific heat formula to figure out how much colder your cup of water will gradually become. On another side, indirect calorimeters are amazing tools to determine malnutrition through respiration chemical output. This way, a disorder could be detected and we could extend a life. Well, thank you for listening and watching this presentation. I hope you are much more informed of the description functions of the calorimetry and its history. Here are some references that you could follow to understand a lot more about calorimetry. Thank you.